Welcome to our deep dive into transformers. They're these really powerful deep learning models, and they're kind of revolutionizing
Yeah,
how we interact with language and so much more. Yeah. You're probably already using them every day and you don't even realize it.
this is true.
Like, things like machine translation and chatbots,
Right.
even those like crazy AI images that you see everywhere.
Absolutely. Their impact is only growing. What's so remarkable is how they've managed to surpass what we could do before, especially with those longer sequences of data.
You're talking about RNNs, right?
Exactly. Recurrent neural networks.
Okay.
They were like marathon runners,
Yeah.
processing information step by step, word by word. But their weakness, their Achilles heel, was their limited memory.
Oh, okay.
They struggled to remember information from earlier in the sequence, especially as the sequence got longer. Imagine trying to understand a story, a complex story, and you forget the beginning by the time you reach the middle.
Right.
Not very effective.
No, definitely not ideal for making sense of anything too complex.
Right.
So how did transformers solve this memory problem?
They kind of changed the game completely. Instead of processing things sequentially, they introduced this revolutionary concept, attention.
Okay.
It's like giving the model a superpower to focus on all parts of the input simultaneously, allowing it to make connections even across long distances.
That's where that attention is all you need paper comes in, right?
Precisely.
Yeah.
That 2017 paper, Watershed Moment,
Yeah.
it argued that you could get better results by focusing on just attention mechanisms, ditching that whole recurrent structure altogether.
What a bold statement. So how does this tension actually work? What's happening under the hood?
Imagine you're reading a sentence and you come across a pronoun like it. To understand what it refers to, you instinctively look back at the previous words to find the noun it replaces.
Right.
That's basically what self-attention does. It allows the model to weigh the importance of each word in relation to every other word in the sequence, creating this map of relationships and dependencies.
So it's like giving the model like a highlighter, right? So it can like pick out
Yeah,
the connections. Yeah.
that's a great analogy.
Yeah.
And to visualize this, I highly recommend checking out the Illustrated Transformer blog post. It's got these brilliant diagrams that show how attention scores are calculated and how they highlight the relationships within the text.
I've seen those diagrams. They're very helpful. But I've also heard that when it comes to transformers, bigger is often better. What's the deal with that?
It's true. There's a fascinating correlation between model size and performance. The Scaling Laws for Neural Language Models paper explored this, and what they found was amazing.
Okay.
Larger models with more parameters can capture more subtle patterns and nuances in the data, leading to better performance on all sorts of tasks.
Wait, hold on. What are parameters exactly?
Think of parameters as the knobs and dials that control the model's behavior. They're numerical values that get adjusted during the training process. The more parameters a model has, the more fine-grained control it has over the data, letting it make more precise predictions.
So it's like having a more detailed map, right? With more points of reference? Okay.
And this has led to this race to build bigger and bigger models, pushing the boundaries of AI. Google's Paul-M model, for example, has a mind-blowing 540 billion parameters. It's really a testament to how far computing power has come and our desire to unlock the full potential of these models.
That's crazy. But it makes me wonder, are transformers limited to just language? It feels like I've seen them doing some impressive things with images and other types of data too.
You're absolutely right. Transformers aren't just for language anymore. They're breaking free, making waves in all sorts of fields.
It's like they've discovered this like universal language for
Right.
understanding data, like
Yeah.
no matter the form.
Uh-huh.
So what are some of the most exciting areas where they're like making a difference outside of just, like natural language processing?
One area that's really cool is computer vision. Vision transformers, or VITs.
Okay.
They're really changing things up in the world of image recognition.
VITs, yeah, I've heard of those, but I admit, like, I don't fully get how they apply this idea of attention to images.
Yeah.
It's not like an image has a sequential order like words in a sentence.
That's a great question. So instead of processing pixels one by one, VITs break down the image into these little patches, and they treat each patch as a separate word.
Oh.
Then they apply self-attention to analyze the relationships between those patches, capturing the global context, understanding how different parts of the image relate to each other.
So it's like having an AI that can see the whole picture, literally.
Literally, yeah, exactly.
That's really cool.
Yeah.
And what about other applications beyond language and images? Where else are we seeing these transformers pop up?
They're being used in robotics, helping robots understand their environment and make decisions. They're being explored for music generation, creating original compositions that can rival what humans can do.
Mm-hmm.
And they're even being used in scientific discovery, things like predicting protein structures, which has huge implications for medicine and drug development.
Mm.
Remember AlphaFold?
Of course.
Yeah.
That was a huge deal. AlphaFold, it used transformers to predict protein structures so accurately, like way better than we've ever been able to do.
Exactly. It just shows how versatile this architecture is. And maybe one of the most exciting and potentially transformative areas of research is in multimodal transformers.
Multimodal transformers, that sounds pretty interesting. Tell me more.
Okay. Imagine a model that can seamlessly understand different types of data all at once.
Mm-hmm.
Text, images, audio, even sensor data.
Wow.
That's the goal behind multimodal transformers.
So instead of having separate models for like language and vision and audio, we could have this one mega model that
Yeah,
just...
exactly. Exactly. It's like building an AI that can experience the world through multiple senses, just like humans.
Yeah.
And this could change everything.
So like, give me an example. What kind of real world problems could these multimodal transformers tackle?
Take a look at Elavi, for instance. It's a multimodal model that combines a language model with a vision model. You can show it an image, and it can describe what's in it, but it can also answer questions about it, generate captions, even have conversations about what it's seeing.
That's amazing. It's like having an AI tour guide that can tell you all about your photos.
Yeah, exactly.
Okay, cool. Where else are we seeing these multimodal transformers making an impact?
Well, they're being used in medical diagnosis,
Okay.
where they can analyze medical images, patient records, lab results.
To provide a more accurate...
Yeah, a more accurate and comprehensive diagnosis.
Yeah.
They're also being explored in robotics to help robots understand and interact with the world, integrating visual, auditory, and tactile information. And get this, they're being used in personalized education.
Wow.
They can tailor learning experiences to each student by analyzing their learning patterns and preferences.
It seems like the possibilities are truly endless, but I do have a question. We've talked about these massive models with billions of parameters. Isn't there a downside to all this complexity? Don't they require like tons of computing power to run?
You're right. The computational costs can be pretty significant.
Hmm.
Training a massive transformer model can use a lot of energy and resources, which raises concerns about sustainability and accessibility.
So it's not exactly like a green technology, is it?
Not quite yet, but researchers are aware of this issue, and they're exploring ways to make these models more efficient.
Okay.
One promising direction is the development of sparse transformers.
Sparse transformers, what are those?
Well, basically, sparse transformers are designed to be more selective about what they pay attention to. Instead of focusing on every single word or every single image patch, they zero in on the most relevant ones.
So they've learned to like skim and scan.
Exactly.
Pick out the good stuff.
Models like Mixtral are showing us what's possible with this approach, getting great results with way fewer computations. It's a step towards making these powerful models more accessible and sustainable.
That's great to hear. But I can't help but wonder, like, where does this all lead? What does the future hold for transformers? Are we on the verge of, like, creating AI that is smarter than humans?
That's a question that's both exciting and maybe a little scary. While we're still far from achieving AGI, artificial general intelligence, the progress in transformer research is really pushing boundaries. One interesting direction is integrating transformers into AI agents.
AI agents? That sounds like something out of, like, a sci-fi movie.
It does. But it's becoming more and more real. Imagine AI agents that can understand your instructions, interact with the world, and complete complex tasks, all powered by transformers.
So, like, self-driving cars and robot butlers.
Well, not quite yet, but those are definitely possibilities. We're seeing early examples of this with models like Cog Agent, which can interact with graphical user interfaces, understand images from the real world, and even do simple tasks like booking appointments or ordering food.
That's wild. It sounds like we're entering a whole new era of, like, human-computer interaction. But with all this power comes responsibility, right? We need to make sure these AI agents are, like, aligned with our values and used for good.
Absolutely. As these AI systems get more powerful, we have to consider the ethical implications. We need to think about transparency, accountability, and fairness, and design safeguards to prevent unintended consequences.
It's a lot to think about, for sure. But it's important to have these conversations now.
I agree. And it's not just up to the researchers and developers. It's a conversation that needs to involve everyone. Policymakers, ethicists, and society as a whole. We need to work together to shape the future of AI in a way that benefits all of us.
Wow, it's really a fascinating and complex topic. As we're wrapping up our deep dive into this world of transformers,
Yeah.
what stood out to you the most? Was there a development or an application that really sparked your imagination?
For me, it's the ingenuity and creativity in this field that gets me every time. Like just a few years ago, transformers were, this niche research topic, and now they're powering some of the most advanced AI systems in the world. It's amazing what human curiosity can do.
Yeah, totally. It feels like we're watching a revolution happen right in front of us.
Yeah.
And we're just getting started.
And that's what's so exciting about it. We're not just building tools, we're shaping the future of like how humans and AI will interact. It's a big responsibility for sure, but also an incredible opportunity to solve some of the world's biggest problems.
Yeah, it is inspiring to think about that potential impact. We've talked about everything from revolutionizing healthcare with AI diagnosis to AI assistants that are so intuitive and helpful. But what about the creative stuff? Are transformers changing art and expression too?
Absolutely. We're seeing like a huge wave of AI-generated art, music, even storytelling. Transformers are creating stunning visuals, writing music, even writing stories. It's blurring the lines between human and machine creativity in some really fascinating ways.
Well, that's an interesting question then. As AI gets more sophisticated and their creative output gets more impressive, how do we even define authorship and originality?
That's something that philosophers and legal experts are trying to figure out right now. It challenges how we think about creativity and makes us rethink what it means to be an artist in a world where AI can create things that rival human ingenuity.
It really is a fascinating question, and it just shows you the impact AI is having on society as a whole. As we keep developing these powerful technologies, we need to keep having these conversations about ethics and making sure they're used responsibly.
I totally agree. It's not just about the tech. It's about making sure AI empowers us and makes our lives better.
Well said. So, as we wrap up our deep dive into the world of transformers, what's one key takeaway you'd like our listeners to remember?
I think the most important thing is to remember that transformers, even though they're incredibly powerful, are tools. And just like any tool, they can be used for good or bad. It's up to all of us to make sure they're used to build a better future.
That's a great point. And on that note, I want to leave everyone with a final thought. We've talked about all the amazing things transformers can do, from translating languages to writing code to understanding images, even pushing the limits of creativity. But what really excites me is what we haven't even discovered yet. What new applications will we see? What problems will we solve? And most importantly, what will you create? The possibilities are really endless. Thanks for joining us on this deep dive.